Okay, so we're given two vectors, which are on the coordinate plane, and we're going to try to add them today and see how and what the result looks like. So, let's just say I have two vectors here. I'm going to draw them. So, one vector is going to be like this. Okay, that's my first vector. Now my second vector is gonna be like that. So great, I have two vectors and now I'm gonna add them. Before I add them, I'm just gonna demonstrate something. We all know that these two vectors are different. However, what about these two? The blue one and the blue one. Are the two blue vectors the same? Yes or no? The answer is yes, because vector is all about magnitude and direction. The magnitude or the length of these two vectors are the same. I mean, I just copied and pasted it, right? And I didn't shrink it or zoom it in. So the length is the same, and we also have this pointing to the same direction. I mean, it overlaps like this, so it points to the same direction. So these two vectors are actually equal. They're the same vector. Now what about these two? So these two vectors are also going to be equal because they still point to the same direction and they have the same magnitude. So the three blue vectors are equal. What about some green vectors? Now, is this green vector equal to the original green vector? The answer is yes. They have the same magnitude and the same direction. What about this? Now this green vector is also equal to the other two green vectors because it has the same magnitude and direction. Okay, so now that we kind of get the point, that vector only matters when it comes to magnitude and direction, we can start to do some math. So, what if I just call my blue vector vector A? I want to add it to vector B, which is my green vector. So what is this equal to? So we first want to understand what the answer is. Is it a number? Is it a direction? Is it another vector? Is it, I don't know, is it a range? The answer is that it is another vector. So vector A plus vector B, let's just use vector C to represent the result. Now I'll draw vector C in red. So one vector plus another vector gives you a new vector. Okay, so how about we just try and add the two vectors together and see what the new vector looks like. So how exactly do we visually represent adding two vectors? Because I know that I have a lot of vectors here, and all of the vectors of the same color are equal. However, how exactly do I place my two vectors so that the resulting vector is the sum of it? Do I do this? Well, no, because what we do here is we want to see the impact of, we want to see how much we moved after we move the distance of the two vectors. So what does this mean? So when I want to add two vectors, I connect them head to tail, like this. The blue vector has a head, or the side of the arrow, that collides with the tail, or the side of that arrow, with the green vector. So, right now, this is the addition. So this is the addition of our two vectors. So now I'm going to draw our third vector, and you will see how it looks like. So we start from one point. We start from the tail of the blue vector. We draw a line. So we draw a line. And we end at the head of the green vector, and we draw an arrow here at the head of the green vector. So this red vector here is going to be our vector C, and it is the sum of our new vector. Now this is because essentially what I'm doing here is I first moved 1, 2, 3, you can say I first moved 3 units to the x direction, right? And then I chose to move, you can say I chose to move another 3 units. 1, 2, 3 to the x direction. So in total, my red vector here has moved, the red vector here has moved a total of 6 units, because that's the sum of the x units that the blue and green vector moved. Now what about the y direction? In the y direction, we can say that we moved 1, 2, 3. We can also say that, so if we just shrink the units of it, we have 1, 2, 3. Okay, so we can say we moved 3.5 units upwards. Okay, so we moved 3.5 units upwards, and then you can say we moved 2.5 units downwards. So that's a total of actually moving 1.5 units upwards, as the red vector here does. So I hope that makes sense. So now that we have the addition of vectors, and we know how this works, so basically the red vector is like the sum of the number of units that were moved in the x direction, the sum of the number of units that were moved in the y direction. Let's just do it in a more mathematical way. So basically, I want to add vector A plus vector B equals vector C. So how do I represent this mathematically? With numbers, not graphs. So let's say I wasn't allowed to draw the graph for some reason, but I was given that the blue vector is 3 and 3.5. And then I can add this to, so I was given this equation and I wasn't allowed to draw the graph. So the green vector is 3, negative 2.5. I want to add this. And what's the resulting vector, the question says? Okay, so what do I do here? Well, essentially, from our original graph, we realize that the red vector, this one, so the red vector, so if I just erase this so you guys don't get confused, the red vector is basically the result of if we add the number of units moved in the x direction to each other for the blue and green vector, and we add the number of units moved in the y direction to each other in the blue and green vector. So the answer is basically the number plus the top number, 3 plus 3, which is 6. That's 6 units to the x direction. And for the y coordinates, we have 3.5 plus negative 2.5, which is just 1. So that is the answer for our red vector. So what if I just, decided to add the vectors in a different order? So they're still the same vector, but now I just want to add them in a different order and to see what happens. So are the two expressions equal? We can also try to visualize this now. So if we try to visualize this, then we know that. So we start off with the green vector, which is over here. We make the blue vector glide head to tail like this with the green vector, something like that, right? And then we take the head of the, so I'm going to use this, represent this in yellow. I'm going to take the tail of the green vector, and so that's the origin, and I'm going to link it to the head of the blue vector, which is like this. Okay, so as you can see, in the visual representation, the yellow and red vectors overlap each other. So it seems like they're equal, but why? So logically, so the red and / yellow vector is actually just the sum of the total number of units we moved in the x and y direction. So the sum here doesn't matter. So it doesn't care about which direction we move, which units we move first. So even if I chose to move 3 units to the right and then another 3 units to the right from different vectors, the results are still going to be 6 units. Because when you add 3 plus 3, it doesn't matter in which order you add them. For the y coordinates, it doesn't matter if you go down 2.5 units. It doesn't matter if you go down 2.5 units and then go up 3.5 units, or if you go up 3.5 units first and then you go down 2.5 units. Because in the result, you still went up 1.5 units. So the order doesn't matter. So yes, the 2 vectors added in different orders produces the same result. So this is still gonna be 6, 1. So if I just erase this, and basically now we have the addition of vectors. So thanks for watching.